Z square plus 11z minus 2 by z minus 1 by 4 into z square minus z plus 1 by 4, right? So that can be written as 4 minus 3 as common into z4 minus 3. So divide, first of all, we have to divide and multiply it by z power minus 3, okay? So that it will become this function 8 minus 4 z4 minus 1 plus 11 z4 minus 2 into z4 minus 3. Now multiply these two and then again multiply with z4 minus 3 so that it will become 1 minus z4 minus 1 plus z4 minus 2 by 2 minus 1 by 4 into z4 minus 1 plus z4 minus 2 by 4 minus 1 by 8 into z power minus 3. So that y of z by x of z is equal to 8 minus 4 z power minus 1 plus 11 z power minus 2 minus 2 z power uh, uh, minus 2 minus 2 z power minus 3 by 1 minus 5 by 4 into z power minus 1. Here z power 1 by 4 into z power minus 2 is there. Here z power minus 2 by 1 by 2. 1 by 2 plus 1 by 2 minus 1. So that it will become z power minus 1 by 4 into z power minus 1 minus z power minus 1. That is 5 by 4 z power minus 1 plus 3 by 4 into z power minus 2 minus 1 by 8 into z power minus 3. So that so it is equal to y of z into 1 minus 5 by 4 into z power minus 1 plus 3 by 4 into z power minus 2. Okay. Minus 1 by 8 into z power minus 3 is equal to 8 minus 4 into z power minus 1 into 11 z power minus 2 into 2 into z power minus 3 into x of z. Applying inverse z transform for this one. So that it will become y of n equal to 5 by 4 into y of n minus 1 minus 3 by 4 into y of n minus 2 plus 1 by 8 into 1 by 8 into y of n minus 3 plus 8 into x of n 8 into x of n minus 4 into x of n minus 1 plus 11 into x of n minus 2 minus 2 into x of n minus 3, right? So that y of n by x of n is equal to w of n, that is x of n 8x of n minus 4 into x of n minus 1. Okay, let us take this as w of n, that is 8x of n minus 4 into x of n minus 1 plus 11 into x of n minus 2 minus 2 into x of n minus 3. And y of n equal 5 by 4 into y of n minus 1 minus 3 by 4 into y of n minus 2 plus 1 by 8 into y of n minus 3 plus w of n. So that for this one, we will draw the direct form one structure. Okay, so x of n into 8 minus 4 into x of n minus 1. Okay, 11 into x of n minus 3 minus 2 into x of n minus all will be added and this will be equated to w of n. W of n, this will be added to 5 by 4 into y of n minus 1 plus minus 3 by 4 into y of n minus 2 plus 1 by 8 into y of n minus 3. Okay, this is y of n. This is direct form 1. The adders are, how many adders are there? N plus n plus 1. So n plus direct form. So y of can be written as y of z by x of z. And w of z is w of z by x of z. Okay. So w of z by x of z is equal to 1 by 1 minus 5 by 4 into z power minus 1 plus 3 by 4 into z power minus 2 minus 1 by 8 into z power minus 3 or by cross multiplying w of z into 1 minus 5 by 4 into z power minus 1 plus 3 by 4 into z power minus 2 minus 1 by 8 into z power minus 3 is equal to x of z into 1, that is x of z. Now we will apply inverse z transform from this one. So w of n is equal to x of n plus 5 by 4 minus 3 by 4 into w of n minus 2 plus 1 by 8 into w of n minus 3. Okay, y of z by w of z is 8 minus 4 z power minus 1 plus 11 z power minus 2 minus 2 into z power minus 3, right? So y of z is equal to 8, 8, this whole expression into W of Z. Now apply inverse Z transform for this one. So Y of n will become 8 to make W of n minus 4 into W of n minus 1 plus 11 into W of n minus 2 minus 2 into W of n minus 3, right? Okay, for this one, we will draw the direct form too. Okay, 8 into 8 into W of n minus 4 into W of n minus 1 plus 11 into W of n minus 2. Okay, minus 2 into W of n minus 3. And this is x of n is x of n, which x of n plus 5 by 4 into x of W of n minus 1. Okay, plus minus 3 by 4 into W of n minus 2 plus 1 by 8 into W of n minus 2. All will be added so that it is nothing but Y of n. So here the multipliers are m plus n plus 1. So that 7 multipliers are there, adders are m plus n, 6 adders are there. Okay. That memory is maximum of m and n. So maximum of m and n is 3, n is also 3. That is 3. Next, transpose structure. This is nothing but the transpose structure. This will be derived from direct form 2. Okay. Inputs and outputs are interchanged. Directions will be interchanged. And node and summing points will be interchanged. Okay. Right. This is about the problem. Next problem is realize the following system. Y of n is equal to minus 0.1 into y of n minus 1 plus 0.2 into y of n minus 2 plus 3 into x of n plus 3.6 into x of n minus 1 plus 0.6. Okay, 0.6 into x of n minus 2. By using direct form 1, direct form 2, transposed form, cascaded form, parallel form, realizations. Okay, all five techniques. Under 5 techniques, we have to solve this problem. Okay, already we already solved the problem using direct one form, direct two form, and transposed form, transposed structured form. Now we will see the cascaded realization, okay, and parallel form realization, cascade from realization. So y of n is given as minus 0.1 into y of n minus 1 plus 0.2 into y of n minus 2 plus 3 into x of n plus 3.6 into x of n minus 1 plus 0.6 into x of n minus 2, right? Applying Z transform on both sides so that it will become y of z is minus 0.1 into z4 minus 1 into y of z plus 0.2 into z4 minus 2 into y of z plus 3 into x of z, right? X of z plus 3.6 into z4 minus 1 and x of z plus 0.6 into z4 minus 2 into x of z. Taking y of z as common so that it will become y of z into 1 plus 0.1 into z4 minus 1 minus 0.2 into z4 minus 2 is equal to 3 plus 3.6 into z4 minus 1 plus 0.6 into z4 minus 2 whole into x of z, or taking a transfer function of y of z by x of z is equal to 3 plus 3.6 into z4 minus 1 plus 0.6 into z4 minus 2 by 1 plus 0.1 into z power minus 1 minus 0.2 into z power minus 2. Okay. So now divide and multiply this by z power 2 by z power 2. Okay, it will become 3z square plus 3.6 into z plus 0.6 by z square plus 0.1 into z minus 0.2. Okay, or we can write this as this is quadratic equation, so it has roots. So 3z plus 0.6 into z plus 1 by z plus 0.5 into z plus 0.5 into z minus 0.4. Okay, so we can write this as h of z equal to 3z plus 0.6 by z plus 0.5 into z plus 1 by z minus 0.4. Or we can write this as divide this by z so that 3 plus it will become 3 plus 0.6 into z inverse y 1 plus 0.5 into z inverse. Similarly, 1 plus z power z inverse y z power minus 1 by 1 minus 0.4 into z power minus 1. So this is h1 of z and this is h2 of z. h1 of z into h2 of z. Okay. So hk of z is nothing but ak plus bk into z power minus 1 by 1 plus ak into z power minus 1. It is equal to yk of z by xk of z or yk of z by wk of z into wk of z into xk of z. What wk of z by xk of z is nothing but 1 by 1 plus ak into z power minus 1. Okay, this is wk power z plus wk power z into ak into z power minus 1, that is xk of z. So wk of z is equal to xk of z minus ak into z power minus 1 into wk of z. Okay, okay. So now wk of n is xk of n minus ak into wk of n minus 1. That will be taken as equation number 1. Okay. Now yk by yk of z by wk of z is equal to ak plus bk to the bk into z power minus 1. By cross multiplying, we will get yk of z is equal to wk of z into ak plus bk into z power minus 1. Cross multiplying it. So it will become ak into wk of z plus bk into z power minus 1 into wk of z. Or yk of n equal to ak into wk of n plus bk into w of n minus 1. Let it be taken as equation number 2. Okay. Now we'll take hk of z as xk of n, yk of n. So wk of n into ak minus 0.5 into wk power n minus 1. Okay. Plus wk power n minus 1 into 0.6. Okay. So like this, you can take the h1 of z. H1 of z is 1 of z is 3 plus 0.6 into z power minus 1 by 1 plus 0.5 into z power minus 1. Okay. So 3 plus 0.6 into z power minus 1. So 3 plus 0.6 into z power minus 1. Okay. By 1 plus 0.5 into z power minus 1. 1 plus 0.5 into z power minus 1. So this is yk of n. Okay. So this will be cascaded with the second one, h1, h2 of z. Okay. h2 of z is what is h2 of z? 1 plus z power minus 1. So 1 plus z power minus 1. 1 plus z power minus 1 by 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 1 minus 0.4 into z power minus 1. So this is 1 minus 0.4 into z power minus 1. Okay. So this is by so like this, we can write h of z is equal to h1 of z into h2 of z. Next form is parallel form realization. Okay. Parallel form realization. So parallel form realization is that is h of z is given as y of z by x of z, that is 3 plus 3.6 into z power minus 1 plus 0.6 into z power minus 2 by 1 plus 0.1 into z power minus 1 minus 0.2 into z power minus 2, right? Okay. We can write this as divided and multiplied by z square, so that it will become 3z plus 0.6 into z plus 1 by z plus 0.5 into z minus 0.4, or we can write this as 3z square plus 3.6z, okay, plus 0.6 by now divide this by z, both LHS and RHS by 1 by z, so that z into z plus 0.5 into z minus 0.4. Okay. z minus 0.4. So using partial fractions, so a by z plus b by z plus 0.5 plus c by z minus 0.4. So a, b, c can be calculated using partial fractions method. So a is minus 3, b is minus 1, and c is 7. Okay, so that it will become minus 3 by z minus 1 by z plus 0.5 plus 7 by z minus 0.4. Okay, so that it will become h of z is equal to 3z by z, that is minus 3 plus minus z by z plus 0.5 plus 7z by z minus 0.4. So it is minus 3 plus minus 1 by 1 plus divide it by z. Okay, multi, minus 1 by 1 plus 0.5 into z plus 7 by 1 minus 0.4 into z power minus 1. Okay. Okay. Then it will become a plus, this is in the form of a plus h1 of z plus h2 of z. So hk of z is ak by 1 minus ak into z power minus 1. It is equal to yk of z by yk of z, xk of z, right? So this is ak, xk of n is it is ak plus a ak ak by ak by 1 minus ak into z power minus 1. Okay. This is hz of k. So parallel form can be written like this. This is a is minus 3 added. Then it is what is h1 of z minus 1 by 1 plus 0.5 into z power minus 1 minus 1 by 1 by 0.5, so minus 0.5 into z power minus 1. Similarly, second h2 of z is 7 by 1 minus 0.4 into z power minus 1. Okay, 7 1 minus 0.4 into z power minus 1. They all will be summed here. Okay, this is the parallel structure technique. Okay, right. Then coming to the FIR digital filter structures, or these are also called as non-recursive realization techniques. FIR digital filter structures are non-recursive realization techniques. Okay. Okay. There are three well-known techniques to realize FIR digital filters here. What are they? What are those three techniques? What are those three techniques? See, here the three techniques are, first one is direct form realization or transversal realization. Okay, or tap delay line filter. This is having three names: direct form realization or transversal realization or tap delay line filter. Second one is cascade realization. Okay, third one is linear phase realization or minimum number of multiplier realization technique. Okay, right. We have three techniques in FIR digital filter structures. Three techniques. First, what is first one? Direct form realization. Direct form realization or transversal realization or tap delay line filter. Okay. Second one is cascade realization. And third one is linear phase realization or minimum number of multiplier realization techniques. Minimum number of multiplier realization techniques. Okay. Coming to the first one. Okay, coming to the first one. First one is direct form realization technique. Direct form realization technique. So if the system is having finite duration impulse response sequence, then it is called FIR system. If it is having finite duration, non-recursive system, this is a non-recursive system. This is having finite duration impulse response sequence. Then it is called FIR system. So here the present output depends upon the present input and past input sequences. Okay. If the length of impulse response is n, that is h of n is equal to h of 0, h of 1, h of 2 up to h of n minus 1, a set of h of 0, h of 1, h of 2 up to h of n minus 1. So the transfer function h of z can be obtained as y of z by x of z is equal to z transform of h of n. Okay, h of n, z transform of h of n is nothing but h of z, that is sigma n equal 0 to n minus 1 h of n into z power minus n. This is the formula for z transforms. Okay, sigma n equal 0 to n minus 1 h of n into z power minus n, right? Z power minus n. So that is equal to, replace n by k, so that it will become sigma k equal to 0 to n minus 1 h of k into z power minus k. Or y of z is equal to, y of z is nothing but h of z into x of z, right? Okay. So sigma k equal to 0 to n minus 1 h of k into z power minus k into x of z, right? So applying inverse Z transform and linearity property, we will get inverse Z transform of y of z, that is y of n, is equal to inverse Z transform of sigma k equal to 0 to n minus 1 h of k into z power minus k into x of z, right? So inverse Z transform of y of z is nothing but y of n is equal to sigma k equal to 0 to n minus 1 h of k into inverse Z transform of z power minus k into x of z. That is nothing but a linearity property. Okay. So time shifting property, so that it will become sigma k equal to 0 to n minus 1 h of k into inverse Z transform of z power minus k into uh, x of z will become x of n minus k. Therefore, y of n is equal to h of 0 into x of n plus h of 1 into x of n minus 1 plus h of 2 into x of n minus 2 up to h of n minus 1 into x of n minus n minus 1. Let it be taken as equation number 1, right? After that, so we'll draw the structures. So x of n, h of 0 into x of n, z power minus 1 into x of n minus 1. So h of 1 into x of n minus 1. X of n is h of 0 into x of n plus x of n minus 1 into h of 1 plus x of n minus 2 into h of 2 and up to x of n minus 2 into uh, h of n minus 2 and finally x of n minus 1 into h of n minus 1, like this. So this is the structure of the above equation. Okay, h of 0 into x of n plus x of n minus 1 into h of 1. Okay, like this. Okay, this realization requires total number of multipliers or n number of multipliers. Total number of adders are n minus 1 number of adders and memory locations are n minus 1 locations. This is about the first form, that is form 1. Form 1, or it is also direct form realization, or also named as transversal realization or tap delay line filter. Tap delay line, filter, right? So next technique is cascade realization technique. What is that? Cascade realization technique. Okay, this realization is implemented all the subsystems of system function h of z can be connected in series, that is cascaded one by one. The output of the first one is connected to the input of the second one. Similarly, output of the second one is connected to second stage output is connected to input of the third stage. Third stage output is connected to input of the fourth. That is cascaded manner. So here we'll derive this cascade realization like this. First of all, we'll take case one. If n is odd, then h of z, the response h of z will be obtained as phi of k is 1 to n minus 1, 1 plus this is hk of z, hk of z. So it is phi of this is a phi of k is 1 to n minus 1 by 2 of hk of z. So phi of k is 1 to n minus 1 by 2 of what is hk of z, b naught of k, b naught k plus b1 k into z power minus 1 plus b2 k into z power minus 2 like that. So it will become h1 of z into h2 of z into h3 of z up to hn of z. Okay. So if n is odd, then n minus 1 by 2 is nothing but even number. Okay. And h of z have n minus 1 by 2. Okay. Second order systems. So hk of z is equal to yk of z by xk of z. It is equal to b naught of k plus b1 k of into z power minus 1 plus b2 k of z power minus 2. So hk of n is equal to yk of n is equal to b0k into xk of n plus b1k into xk of n minus 1 plus b2k into xk of n minus 2. Let it be taken as equation number 1. Okay, for this one, write the structure. So xk of n into b naught of k plus b1 of k into xk of n minus 1 plus b2k into xk of n minus 2. All will be added and it is nothing but yk of n, right? So xk of n, hk of n is nothing but hk of n, h1 of z, h2 of z like that. Okay, so it is b01 into x of n plus b11 into x of n minus 1 plus b21 into x of n minus 2. This is nothing but h1 of z into b02 into x of n plus b12 into x of n minus 1 plus b23 into x of n minus 2 is h2 of z up to b naught into n minus 1 by 2 into x of n plus b1 n minus 1 by 2 into x of n minus 1 plus b2 n minus 1 by 2 into x of n minus 2. This is nothing but h of h of hn minus 1 by 2 of z. So all will be cascaded so that we will get the response for n is odd. Okay, suppose if n is even, so this will this will discuss in next class. So time is up. Okay, so with this I am concluding the today's class. Okay, so if n is even, we'll discuss it in next class. Okay, thank you.